Hi guys, welcome back to the channel. In this video we are going to use PySpark to load the JSON files we downloaded from the API in part 1. We are going to utilize PySpark instead of pandas, since pandas is for small and mid-sized datasets, while PySpark is for big datasets. The main difference between pandas and PySpark is that pandas runs operations in a single machine, whilst PySpark runs on multiple machines. The first thing we need to do is to install PySpark on our machine so we can spin up a cluster. After installing PySpark on our machine, we need to import PySpark and PySpark SQL, as you can see on the first few lines on my editor here. From PySpark SQL, we need to import Spark session, and from PySpark SQL.types, we need to import struct field, struct type, string type, integer type, date type, and float type. These are the data types in PySpark, and it's good to import them from the beginning. And from the SQL functions, we need to import explode, concat underscore ws, to date, call, monotonically increasing ID or number, regex replace, when, split, length, and trim. All these are functions that you can use on a PySpark data frame, and today we are going to use most of them. And of course we need to import the dot window, which brings all the window functions, like all the equivalent analytical functions in Oracle database. I have written the code already because it's a lot of typing, but we will go step by step and we will print out all the results for you to see, how things work using PySpark. So if I scroll down to the bottom, we have in our main function, we are going to run the load to PySpark function, which is this one. Here we are going to create a Spark session, so we have to type Spark session dot builder dot app name, you can give whatever name you want, dot get or create session, and that will create a Spark session. Using Spark session now, we can read all kinds of data from our local drive, and here we use spark.read.json and we load all the JSON we have in this directory. Remember, from part 1 we created, I think, 10 JSON files that contains data, and here this option here we write dot option. PySpark Dataframe has plenty of options, so you can see if you search on the internet you will find many, but for here, if you type in first schema and true, that means PySpark will try to identify the data types as it loads the data. Another cool thing about this line here is you see we don't specify which JSON file we want to load. We don't have to do that. It loads all the JSON files in this directory at once, so it's pretty cool. Unlike pandas, in pandas you need to iterate through all the JSON files, but in PySpark you can load them all at once. And then we have to use explode. Why? Because when we load the data, it will give you an array. Let me print the data. So in PySpark you don't use print, you use dataframe.show, and it's going to show you to print all the data frame, the PySpark data frame. Another difference with pandas. Let's run the code and see. It takes a while because you need to spin up a cluster, so you will see it takes a while. But here we have the data, right? You see drinks. And it loaded all the JSON files, but as arrays. So we have nested dictionaries inside an array. Now, what happens when you have an array in PySpark data frame, like in pandas, you have to use explode. You can do that by typing df.select, and then inside the select, explode the column that you want to explode in this in this case is drinks, you can provide an alias and .show, and that would give you this. So we created another data frame, and here we have now all the data is not inside an array anymore because we exploded the array, and we have the dictionary, the Python dictionary with all the data. However, that's not good enough, because here again we would need to flatten the dictionary to get the data. So there is another way. Actually, before I move to the other way, let me tell you about this command here, print schema. Print schema in PySpark data frame, it prints the data types of the data frame, right? And if you see here, it gives you drinks is actually an array, and inside the array we have elements type struct, and inside that structure here we have the columns, and the columns like date modified, this is a string column. ID drink is a string column. All PySpark by default identified all these columns as strings, although some of them are integer or floats. So the infer schema option here is not always correct, and we can specify the schema ourselves, and this is the correct way to do it. You have to specify the schema and pass it to the PySpark data frame, and that would give you the proper data types. But let's remove these lines here, because as we said, we exploded the array, but still we have nested data. What we want is to get all the columns and the data inside those columns, and we can do that by using another command. Let me comment that out and bring that back in. We can use that by using the concat_ws, which is the equivalent of list ag in Oracle SQL. That means the array, it converts an array into string and concatenates all those strings if there are multiple strings based on the symbol that you give them. If I type comma, it's going to separate, it's going to create a string separated by commas. But let's not pass anything for now, it's not necessary. And here, so that concat_ws will create a string from the array, and we are going, and the array that would be the df drinks date modified. So how do you get nested data in a data frame? You have to type dataframe dot drinks, which is the column I showed you here, and inside this column we have data, right? And then if you type the column name drinks.date modified, it will give you the data, the nested data. As you see here, this is a structure, drinks, this is an array, and inside the array it has columns. Date modified is string. So if you type dataframe dot drinks dot date modified, you will get the nested data. And we provide an alias, of course, and to date, because it's a string by default, so we convert it to date, and then we do the same for all the rest of the columns that we want in order to create this PySpark data frame here. So we would need the ID drink. We cast it as integer. This is how you cast data types, like a whole column in PySpark dot as type, integer type, and this integer type here is coming from the imports here, right? We imported all these PySpark data types. You cannot use Python data types, you can only use PySpark data types. And if you type dot as type, integer type, it's going to load it as integer. And we select a few other columns as well: alcoholic, category, drink, video, glass, instructions. And instructions, we convert it to string type as well, just to show you how it can be done, and we provide the alias here. So if we run this, save and run, you will notice we create a new data frame which has all those columns, and we have converted some of them in different data types. Now let's wait. Okay, here we are. You see, that's the PySpark data frame, right? And all these values here. We have the date modified, ID drink, string alcoholic, string category, str video, string glass, etc., etc., right? And now if you see the schema here, the date modified is a date, the ID drink it's an integer, and everything else it's a string. Now, so from the data we loaded, we are going to separate those data into 3 different data frames, and we are going to perform some transformations and calculations to see how we can do that using PySpark. Let's move on to the second data frame, and here we get all the measurements. If we do that, so let me comment that out, because PySpark actually takes a bit of time. It's for big data, so it's not very efficient when you use it for small data sets, but the purpose of this video is to demonstrate how PySpark works and why it's much better than using pandas in big data sets. Now, as you see, that's our second data frame. We select the ID drink, the measure 1, the measure 2, and measure 3. It describes the measures for its cocktail. Now, let's say we want to create an unique ID for this data frame, right? Let's like an incremental like a sequence that we have in Oracle SQL. We want to create an incremental sequence, and that would be our surrogate key. And there are there are 2 main ways of doing that. We will see both. The first one would be to use the zip with index function. But before we use this function, you cannot use it straight on the data frame, on the PySpark data frame. You have to convert PySpark into RDD, which is, I think, stands for Resilient Distributed Dataset. And it's not a pandas data, it's not a PySpark data frame. This is RDD, which is again PySpark, but not a data frame. And so we convert the data frame to RDD, and then we apply this zip with index function, and then we convert this resilient distributed dataset back to data frame using this command .df. Now, if we print that again, it's going to give us an extra column with incremental numbers. Let's try that. Now, as you can see, it takes more time because we convert a data frame into RDD and then back to a data frame, right? And it's going to give us this. So the first one is column number 1, and then that's column number 2. So it creates an outer column, let's call it an outer column, and inside it has all the nested columns. And in here we have the second column, all the incremental numbers. How can we, just this is unnest the nested columns here. We can do that by this command here. We select all the columns. So call is actually a function that we imported here from the PySpark.sql.functions, and we select all the columns, all the nested columns under column 1, and we also select column 2, and we provide an alias that would be increasing ID. Now if we print that, you will see a proper data frame, and let's print the schema as well so you can see what I'm talking about. And yep, it's running. Remember guys, PySpark is for big datasets. It takes time to spin up a cluster every time we run it, so just use it when you are using big data. And here we have it. So we have now a proper data frame with an extra column which is a sequence. So we provide a unique ID for this data frame, and here you will see that ID is type long, string measurement is type string, and then increasing ID is type long. So that's the second data frame. Let's comment that out and check the third data frame. Now for this data frame we are going to see how you can create a sequence, but in a different way, and that is by using the window function. Now as you can see, this part here is like before. From the data frame we select specific columns, specific nested columns, we convert them into strings from array, and we load 4 columns here, right? And then with this command here, dot with column, this command with column is used for many reasons, but one of its purposes is to add an extra column, and we do dot with column monotonically increasing ID. That's the the name of the new column, and monotonically increasing ID is a function from the SQL PySpark SQL functions here that we imported at the top, right? And here and then here we need here line number 84, we need to use a window close here, and then do an order by and specify the column that we want to order by, and using our window command, and you will see why, right? Then in the same data frame we do with column, and we create a new column, consec ID, and here we use the window function row number, the equivalent analytical function in Oracle SQL or window function in Microsoft SQL, over, and then here we specify this window close, right? So it's row number over partition by dot order by. It's like an SQL statement. So if you write the equivalent in SQL, that would be row number over, and then partition by blah blah column order by column descending, right? So here in the window function we could use partition by as well, but here it's not necessary. So the equivalent in SQL would be this row number over column order by, sorry, here we remove that, order by column descending order. right? And then we print that. So let me run this. You will see the results. You will see what I'm talking about in just about 3 seconds. That's the second way of creating a sequence in PySpark. You will see we have an extra column here that has unique identifiers for each record in the dataset. Now, this function here, monotonically increasing ID, here this function provides a unique number for each record. So these are random numbers, but unique numbers. And that's why we are using row number for all the dataset over, like monotonically order by this. And that's why every number is now we create this way. We create a sequence. If we partition by a column, it's not going to create a sequence. It's going to give us one for each record, because each record actually is different than the other. But here, if we don't use a partition and use only the order by without utilizing a column to partition the data, it's going to give us a sequence. This is the second way of actually creating a sequence of number. Moving on, we have another transformation here. Let me uncomment that, and you will see when we want, let's say, to add +5 on this column, the monotonically increasing ID, or whichever column you actually want. There is in pandas, we can use apply, and it's going to apply the function for each record in the dataset. Here we need to convert PySpark Dataframe into a resilient distributed dataset first. So PySpark Dataframe df ingredient .rtd .map, and it's going to apply the lambda function for each record. So the lambda function, but you cannot, if you don't convert it to RDD first, it's not going to work. It's going to give an error. So people just convert it to RDD first, then use the map function, and inside use whichever function you want. I used an anonymous function here, lambda, and we return the whole record each time, but we add 5 here on the 4th column, and then we convert the resilient distributed dataset back to Dataframe to df, that's the command, and then we specify the column names again. If you don't do that, it's going to give you numbers as column names. So if you provide a list with the column names, it's going, when you convert it back to Dataframe, you pass the list with the column names, and it's going to work like that. So let me comment that out too, and here save, and you will see what I'm talking about in just about a second. It's running. Here, as you can see, we're getting a warning that we haven't partitioned the data for window operation, and moving all the data into a single partition is not very good for the performance. But here I'm just demonstrating an example of how you can create, a sequence in PySpark. Now back to the addition, you can see on this column we added 5 on each record, and this is how you apply a function to each record in a PySpark data frame. You have to convert it to RDD first. Now another transformation that could be useful is to actually group by string ingredient based on string ingredient ones and the consec ID. Now it doesn't really make sense based on, there's no business logic to do that behind that in order to do that, but just to show you how you can use group by, we have to select the column that we're going to group by, the aggregate function, this is sum, and with column renamed. So when you run the group by and sum, it's going to create the new column, the sum column. It's going to have this naming convention. I don't know why, that's by default in PySpark. So you can rename the column using dot with column renamed and rename the column here as with the name you want, right? And then we can order by, we specify the column we want to order by, and then descending or ascending. We can use order by or sort, they are both the same. I will use sort in a bit, but let me run this. Okay, we're getting the same warning again, of course. But here, as you can see, we grouped by ingredient 1, and we summarized, we provided the sum of the column, of this column, and we ordered that by descending order. That's just another transformation that does not make any sense, but it's useful to know, the group by statements, the aggregate statements, etc., etc. Now, moving on to this second data frame again. Let me remove the comments here. Let's comment that out again, because now we are going to see the second data frame. That's also interesting. So here, remember, we have the df measure that has all the measures, and we have created a new column with increasing ID. And here, what we are going to do here is going to see, actually, if this column here, string measure 1, contains OZ, then regex replace OZ with nothing in this instance. But you can see there we are using contains. If you want to check if there is a substring inside the string in PySpark, you can use contains. It's very convenient, and you can use regex replace if you want to replace a substring. And you can use when. So first of all, you have to use dot with column. Remember, I told you when you want to transform a column, you have to use dot with column, specify the column name here, and then provide all the conditions. The when condition is like the case when statement we have in SQL. So you type when, open parentheses, all these conditions we want, and then if you want another condition, you type dot when again, and if it ends with CL, then replace CL with nothing. Otherwise, just leave it as it is. And if we run that, so it's exactly the same with the case when statement. So we have multiple when conditions, else is the otherwise here, exactly the same. So PySpark converts this into SQL, and you will see that it creates the same results with having a case when statement in SQL. Now, as you saw, it removed all the strings here. You see all the substrings OZ, CL have been removed from this column. We removed them, right? Now, the next step. The next step is a bit more complicated. I will show you why. Let's bring that back in. And here, as you can see, string the measure 1, this is the column. It has, let's say, for this column, we want to keep the integer part in one column, and then the fraction in a second column, and then we want to add them together. So here we would have 1.5, like we have 4.5 here, and here we would have 0.5, or 1.666 here, or 0.75, etc., etc. So we are going to split the integer part and the fraction part, if it exists, and then add them together. So we would have just one number, a decimal number, and we can achieve that by using, again, the with column. We select a new column, the name of a new column, so that would be string measure 1, and we use the when statement again when it contains, if df measure string measure 1 contains slash, so there is a fraction in the column, and so the first case, for example, and then if the length is greater than 3, so it has more than a fraction, it has the integer as well, because as you can see here we have integer and a fraction, and here we have only a fraction. So if it has an integer plus a fraction, we use split, and we split based on the space here. So it will split this string into two strings, and we are going to get the first string and cast it as float type. You will see why as float and not integer in the end, but you can use also the trim function here and trim all the spaces, and then we split exactly as we split strings in Python, and we get the first substring. If it contains slash but the length is less than 3, so if there is only a fraction, then you use as 0 as the integer part. Otherwise you cast everything into float, and then with dot with column we create a new column, and let's say when it contains slash again and it's less than 3, then so here we used for the integer part we placed 0, but now in the second column we need this fraction to go into the second column. So with the same condition you just copy the value to the second column, otherwise you split and you get the fraction get1, which is the second part of the string here, so that would be the fraction. So we move all the fractions to a separate column. Essentially this is what we are doing. Now if let me run this, it will be easier to understand when you see it. Let me run that. Imagine that in SQL we would have multiple case when statements. It's exactly the same thing. It doesn't really changes much, and here we have still running. As you can see, that's the data frame before, and this is the data frame after. So we have two new columns, string measure 1 1 and string measure 1 2, and here we have the integer parts as floats, because we have a float already here, so we convert even if it is an integer, we convert it to a float. And then in the measure 1, in this column here, we move all the fractions, 1 slash 2, and all these fractions here. Now the next step would be to add these two numbers. If string measure 1 2 is not null, add these numbers and create a new column as decimals, and we can do that by this function here. So we convert the data frame into resilient distributed dataset. We use the map function. Remember, if you want to apply a function for each record in the data frame, you need to convert the data frame into resilient distributed data set and then use the map function. And here again I'm using the anonymous function and anonymous function here, and we just return the data frame, its record, but after the transformations have been taken place. And here what we do, we are going to use fraction. So that's a Python library. Let me where do I have it? From fraction here, I have it here. So from fractions, import fraction, and it's going to take a string as an input. It's going to create a fraction, and then we convert it into a float. So we say if the element is not none, so if if it's not null, like here, so if we have a number, it's going to create a fraction and then float, and it's going to create a decimal. Now before we do that, this is going to well, we can print. This is an RDD. Remember, we converted the data frame into RDD. RDD is a bit different than the data frame, so we can run this instead of using .show, because it's not a data frame. So if it's an RDD, you cannot use .show. There is no such function, but you can use collect, and this will print everything that you have in this resilient distributed dataset. And let me show you that. So you have to print, though it's not going to display it otherwise. You have to use print, and let me. So here we are going to see all the data here after the transformations. And okay, here we have an array. Inside the array we have tuples for its record. As you can see, the last column has been transformed to decimal, unless there is nothing there. So this, if you convert it to data frame, it's going to give an error, because the float, this is data type of Python, right? That's coming from Python, not from PySpark. We have to convert the float, the Python float data type into into PySpark, into float type in PySpark. And we can do that by passing the schema. So this is what before, remember I mentioned that you can specify the schema for each data frame. This is how you do that. You type struct type, you open parentheses, and you pass an array, and inside the array you pass for each column you pass the data type, and you need to type struct field, the column name, and what type data type this column is, and true is for nullable or not. So I have defined all these data types here, and the last two are of type float. And what we can do here is, instead of doing 2df, that would give us an error, we create that is going to convert the RDD into a data frame. We use spark.create data frame, which is exactly the same thing, but here we are using the RDD that we created, and here we pass the schema. So when you use the create data frame, you can also pass the schema, which the schema is this one here, and it's going to create a new data frame, and the last two columns would be of type float type, of the PySpark float type. So let me print that and remove here this one and run it, and you will see now that everything would be of float type, the last two columns I mean. And in the meantime, let me uncomment that. So while we are waiting, I can explain this code here. Where this is the new data frame, the updated one. Actually, let's wait for it to finish so you can see the data frame we have up to this point, and this is the new data frame, right? So it converted everything into decimals: 0.66, 0.72, 0.5, 0.5, and now we are going to add those two columns, and we can do that again by using with column string measure, that's the column name, and when it's not null, null here, then combine these two columns. Otherwise, just keep the first column, right? If it's null here, you don't need to add the second column. And then we drop these two columns here that we don't need them anymore. We are going to replace this column here with the decimal types. And let me run it and show you what I mean by that. And still running. Waiting. And here we have the string measure 1, and it contains only decimal numbers: 1.66, 1.5, 0.5, 0.2, 2.0, 0.75, 1.5, etc., etc. That was a good transformation, and this is how you can use the drop here, how you can use drop to drop columns, and how you can use with column and case when statements in PySpark. Now let's move on to the third data frame, which is the df drink, but let me do that first. You can use filter. So this is how you filter data in PySpark. Let me remove that for a second. That's the second, and bring back this one, df measure. Nope, df select, df drink, right? So bring that back in, and here we have the filter, the function filter, and here you specify inside the filter the conditions you want to filter the data frame. So you open parentheses. If you have multiple conditions, you have to open parentheses here and parentheses here, open brackets actually, and you specify the column you want to filter by, and let's say if string class contains class, and then you can also sort instead of order by that I showed you before, date modified descending, and I did ring ascending, and do all this kind of nifty tricks here and transformations. And let me show you that before we move to the last part. And here we have the filtered data frame and sorted by date, etc., etc., and the ID ring. Now all this is cool, and here let's bring that back in. We write to the database. First we have to create an instance of the database, and let me import from my local Python script, import db, and create an instance of this class that is here in the database.py. I have created a connection with Oracle database using SQL Alchemy. Here is, all the properties, the password, etc., and we create engine, and then we create a connection. And here we import this pipec file, and we create an instance of the DB object. And we also create a function that it's called write to database, and we pass the data frame and the table name. Now in PySpark you can write into a database like that, dataframe.write.format. You specify the type JDBC here, options, and in options you pass the URL, the driver, table name, username and password, and then .mode, override, and .save. Mode, there are 3 modes, and usually if you do override, this is like truncate and insert, or you can use append like that, but whatever you want. And if you want to append the data, so if we scroll back to the bottom again, let me comment that. Let me bring back all of this. So we need the df measure updated, and need to uncomment that. Df ingredient as well. And here we are going to run this function. We are going to pass the data frame and the title. So if we do that, ingredient 2, the table, the title, I mean the table name, so measure 2 and ingredient 2. And here the first time we have to use the override mode option, otherwise it's not going to find the table in the database. It's going to give an error. So if we run all this, let me run everything, and you will see in the database it's going to create 2 tables, one called measure 2, one called ingredient 2. As you can see here, we have 2 tables, one with measure 2, and you can see the column names, and here the data types, right? So this is the transformed data frame. Now if you don't create the table yourself and you let PySpark create the table for you, when you are using, if a column is of string type, it's going to be saved as varchar2, that's fine. But by default it's going for 255 bytes. If you have a longer string, it's going to give you an error. So if you have a longer string than that, you need to create a table yourself and then append instead of override as option. But you can see here we have all the data, and if we use append, it's going to append the data that we have here. And ingredient 2, this is the second data frame. This is everything for today, folks. We learned how to use PySpark to load multiple JSON files at once, create data frames and resilient distributed datasets, and how to use PySpark data types and functions to perform transformations, and how to save data frames into a database. I hope you enjoyed the video. Click the like button and subscribe to the channel.